So quickly we'll revise this topic. We have types of fit is a clearance fit, interference fit and transition fit. So in the case of clearance fit, we'll represent the hole with this figure with a tolerance band, and we have a shaft whose both limits are lower than the shaft limit. So this one represents the shaft with tolerance, and it is clearly observed that both the limits of the hole are more than the shaft limits. So maximum size of hole and the minimum size of the shaft is called as maximum clearance, and the minimum size of hole and the maximum size of shaft is called as minimum clearance. So we have maximum clearance and minimum clearance. So the maximum clearance is the maximum size of hole and the minimum size of shaft, and the minimum clearance is minimum size of hole and maximum size of shaft, and the minimum clearance is called as allowance. The example of this one is piston and cylinder and the shaft in journal bearing. The tolerance band of hole is always above the tolerance band of a shaft. Now let's consider the interference fit. In the case of interference fit, the hole is smaller than as compared to shaft, and if we select the maximum size of shaft and the minimum size of the hole, it is called as maximum interference. Maximum interference. And if we select the minimum size of shaft and maximum size of hole, we will get minimum interference. So if this happens, then for male female we required external force to join it. That is called as force fit. So interference fit is also called as force fit. So maximum interference is the maximum size of shaft minus minimum size of hole, and minimum interference is shaft minimum size and hole maximum size. Example is keyway, and the tolerance band is exactly opposite in this case. This time maximum interference is called allowance. And if you have clearance fit, then minimum clearance is called allowance. So definition of allowance you have to make very clear: maximum interference or minimum clearance. And transition we already done in discussion detail. Sometimes may have interference in the case of transition. So in this case we may have a chance of interference fit and transition fit. So tolerance band may overlap. So we'll consider some simple problems here. Let's suppose we have a hole of size 0.046 minus 0.00 and a shaft of 50 minus 0.010 and minus 0.0029, and we want to identify what type of fit we have. So first of all we'll go for hole. So we'll represent a hole like this with a maximum size of 0.46 and minimum size is 50. Both the sides of the shaft are less than 50 here. So we'll construct the shaft below the hole size. This one is tolerance band, this one is shaft with the maximum size of 49.990 and minimum size is 50 minus 0.029 is 49.971. So naturally we have a clearance fit here, and we can have a maximum clearance if we select the maximum hole size and minimum shaft size. So this difference represents the maximum clearance. 50.046 minus 49.971, that equal to 0.075 mm. Multiplying 1000 to this value will get micron. So we have 75 micron. And if we select the minimum size of hole and the maximum size of shaft, you can find minimum clearance. So minimum clearance is 50 minus 49.990, 50 minus 49.990, that equal to 0.01 mm. So minimum clearance is called as allowance. So let's consider here a 100 plus 0.035 is a hole, and the lower is 100.0.000, and we have a shaft of 100 plus 0.025 and 0.003. So if we draw the hole first, the maximum size of the hole is 100.035. So this one is hole, and the minimum size of the hole is exactly 100. So this hatch area represents the tolerance. So if you see the shaft size, it is lower than the higher limit of the hole and more than the lower limit of the hole. So let's construct here shaft first. This is the tolerance of the shaft with the higher value is equal to 100.025 and the lower value is equal to 100.003. So in between the hole tolerance, we have shaft tolerance. So if we select the maximum size of the hole and the maximum size of shaft, you will get minimum clearance now. So this one is minimum clearance. So minimum clearance is 100.035 minus 100.025, that is 0.01 mm is equal to 10 micron. And if we select the maximum size of the hole and the minimum size of the shaft, you will get maximum clearance. So this time we will get maximum clearance. It will be 100.035 minus 100.003, that equal to 0.032 or 32 micron. And if you select now the minimum size of the hole and the maximum size of the shaft, so this will be maximum interference because the shaft is having more size as compared to hole. So 100.025 minus 100 is 0.025, that equal to 25 micron. So this is allowance. And if we select the minimum size of the hole and the minimum size of the shaft, so you will get minimum interference will be 0.03 mm, that equal to 3 micron. 0.003, that is 3 micron. We are given a hole of 32 plus 0.02 and 32.00 and a shaft of 32.010 and 32 minus 0.010. You have to identify which type of fit we have. So our maximum dimension for hole is 32.02 and minimum dimension is 32 only. And the maximum dimension for shaft is 32.01 and the minimum dimension is 31.99. So naturally this one is the tolerance of two bands overlap each other. This represents a transition fit. So choice C is correct. Interference fits are provided for mounting of pulleys on shaft, no. Bush bearing, yes. Assembling of bush bearing in housing. Choice B is correct. In this problem we are given two dimensions of a shaft, 100 plus minus 0.1 and 0.1 plus minus 0.001 mm respectively. We have to find out which of the following statement is true. Tolerance in the dimension is greater than in shaft A. No, that is the same value almost. The relative error in the dimension is greater than in shaft A. The relative error in the dimension is same for both shaft and B. For shaft A, tolerance is 0.2 mm for 100 mm diameter. So relative percentage is 0.2 divided by 100 multiplied by 100, that equal to 0.2%. Whereas for shaft B, which is a diameter of 0.1, the tolerance is 0.002. So we have percentage is 0.002 divided by 0.1 multiplied by 100. So that answer also equals to 0.2. It means that the relative error in both dimensions are same. Choice D is correct choice. We are given a hole of 0.06 and plus are assembled integrally with a pin of 50 plus 0.03 minus 0.01. You have to find out minimum clearance. So hole is larger than shaft. So your maximum diameter of hole is 50.06. Minimum diameter is 50.04. For shaft, the maximum diameter is 50.003 and minimum diameter is 49.999. And we want to find out the minimum clearance. So minimum clearance will be minimum hole size and the maximum shaft size. So this represents minimum clearance, which is 50.04, 50.003, that equal to roughly 37 micron. So micron you obtain by multiplying by 1000. Here we have 50 plus 0.02 and 50 minus 0.01 is the hole size. So 50.02 and 49.99, in between this your hole will vary. Whereas the shaft size is 49.95 and 49.93. It means that hole is always larger than shaft size. So we have a figure like this. The hole maximum size is 50.02, minimum size is 49.99, whereas shaft has maximum size is 49.95, minimum is 49.93, and we want to find out minimum clearance. So minimum clearance will be minimum size of hole and maximum size of shaft. So minimum clearance is 49.99 minus 49.95. This is 0.04 multiplied by 1000. 0.04 mm is approximately equal to 40 micron. In the next question, we have a hole of 50 plus 0.04 and 50.02, whereas the pin is shaft 50.005 and 49.992. So both the dimension of shaft are lower than the hole. So this also represents clearance feet. So we have hole size is 50.04, 50.02, and shaft maximum size is 50.005, minimum size is 49.992. So minimum clearance is 50.02 minus 50.005 is 15 micron. A hole is specified by 25 plus 0.03 and 25.02, and the mating shaft has a transition fit and maximum interference is 20 micron. So we have a hole of 25.03 and 25.02. The tolerance on the shaft is 50 micron. So this tolerance band must be 50 micron. We want maximum interference of 20 micron and we have a transition fit. The maximum interference will be maximum shaft size and the minimum hole size. So this value is 20 microns is 0.02 mm. So 20 micron is, therefore we have 25.02 plus 25.02 will be maximum size of the shaft 25.04, and 25.04 minus 0.009 is 24.99. So actually this dimension should be a little bit lower. So now the figure is correct, 24.99. Now we want maximum clearance. So maximum clearance will be formed if we take the maximum size of the hole and the minimum size of the shaft. So this will be the maximum clearance. So maximum clearance is the maximum size of the hole 25.03 minus minimum size of the shaft 24.9, that equal to 0.04 mm multiplied by 1000 will be 40 micron.